Let's see, we have 2x multiplied by x squared minus 1 being equals to 0. So for this to be true, it's either 2x is equals to 0 or x squared minus 1 is equals to 0. So what are we saying? We're saying that either 2x is equals to 0 or x squared minus 1 is equals to 0. If 2x is equals to 0, then x is just equals to 0 divided by 2, or on the other hand, x squared is equals to 1. So x is equals to 0 or x is equals to 1 or x is equals to minus 1. That is because 1 squared is equals to 1 and minus 1 squared is also equals to 1. And that is the answer to 1.1.1. This is the approach we take when we have a question like this. If two numbers are multiplying each other, or let me say two terms, and the result is 0, the product is 0, then 1 between the two numbers or the two terms should be equals to 0, just like we have in this case. Let's look at 1.1.2. X minus 6 plus 2 divided by x is equals to 0. We're supposed to solve for x correct to 2 decimal places. As soon as I see correct to 2 decimal places, I'm thinking, right, I have to use the quadratic formula. So what can we do here? We have 2 divided by x. So if we multiply out by x, it will make our life very easy. So if we go ahead and do that, we're gonna get x squared minus 6x plus 2, right, is equals to 0. So now we're gonna go ahead and say that x is equals to minus b plus or minus the square root of b squared minus 4ac divided by 2a. This is the quadratic formula. So what is a? A is the coefficient of x squared, and then b is the coefficient of x, and c is the constant term. So x will be equals to minus b, so that is minus 6, plus or minus the square root of b squared, so minus 6 squared, minus 4, a is 1 and c is 2. Everything divided by 2a, a is 1. So x will be equals to 6 plus or minus the square root of 28 divided by 2. So x will be equals to 6 plus 20 plus the square root of 28 divided by 2, or x is equals to 6 minus the square root of 28 divided by 2. So x will be equals to 5.65, or x is equals to 0.35. That is the answer to 1.1.2. We just simply using the quadratic formula. What about 1.1.3? Here we have x minus 1 multiplied by x plus 4 being greater or equals to 6. So what can we do here? How can we possibly answer this question? Well, let me go ahead and find my critical values. In order to find the critical values, we have to forget the inequality first and just say that the two sides are equals to each other, just so we can find our critical values. And then after finding our critical values, we will then form a solution to our problem. So we're gonna say that the square x minus 1 multiplied by x plus 4 is equals to 6. So let's multiply out. X multiplied by x is x squared plus 4x minus x minus 4 is equals to 6, right? So let's take 6 to the left hand side, so that will be minus 6 being equals to 0. So we have x squared plus 3x minus 10 being equals to 0. So the question now is, which two numbers do I multiply and get minus 10? And when I add them, I get plus 3. That is positive 5 and negative 2. So if we factorize this, we shall get x plus 5 multiplied by x minus 2 being equals to 0. So x is equals to minus 5 or x is equals to 2. At this point, we have two possible solutions. It's either x lies between these two numbers. So it's either we have minus 5 and something like this. Is either this is our solution, or we have x being less or equals to minus 5, or x being greater or equals to 2. This is our two possible solutions. So how do we find out which solution is correct in our case? Well, let's look at the first one. The first one, what we are saying basically is that this inequality is satisfied when x is equals to these two numbers or in between them. So let's take a number that is between minus 5 and 2 and see if our inequality is satisfied. If it is satisfied, then the first option will be our answer. But if it is not satisfied, then our second option is the answer. So a number between minus 5 and 2, let's take 1. So let's substitute 1. If we substitute 1, we're going to have 1 minus 1 multiplied by 1 plus 4 being greater or equals to 6. So 1 minus 1, that's 0, right? So everything just falls apart on the left hand side. So we have 0 being greater or equals to 6. And we know that this is not true. So this first option is not correct. Our answer is the second option. Well, that's just the way I think about it. There's other ways of solving this problem. Well, of finding where your value is going to lie. Inside the two numbers or outside. Other people use number lines and so on. Yeah, but this is what I use. 1.1.4. We have the square root of x minus 2 plus 3 being equals to 10 divided by x minus 2. At this point, when I see a term repeating time after time, I'm already thinking I'm probably gonna let this term be equals to k if it's repeating time after time. Well, let's go ahead and try that out. So we're gonna let the square root of x minus 2 be equals to k. So instead of having x minus 2, we're just gonna write k. So we're gonna have k plus 3 being equals to 10 divided by k. So let's take 10 divided by k to the left hand side. If we do that, we're gonna get k plus 3 minus 10 divided by k being equals to 0. This k is troublesome, so let's multiply out by k so that we can have our usual form, something we are used to. If we do that, we're gonna get k squared plus 3k minus 10 is equals to 0. We want to factorize now. Which two numbers do we multiply and get minus 10? And when we add them, we get plus 3, positive 5 and minus 2. So we're going to have k plus 5 multiplied by k minus 2 being equals to 0. So k is equals to minus 5 or k is equals to 2. But we know what k is equals to. K is the square root of x minus 2. And we're saying that this is equals to minus 5. But we know fully well that this doesn't hold. This cannot be true. We cannot take square root of something and get a negative number. So we're gonna cross out this equals to, because the two can never be equals to each other. On the other hand, x minus 2 can be equals to 2. No issues whatsoever. If we square both sides, we're gonna get x minus 2 is equals to 4. So x is equals to 6 if we take minus 2 to the right hand side. That is the answer to 1.1.4. Let's go ahead and do 1.2. So 1.2, we're supposed to solve for x and y. Well, we have x minus 2y being equals to 1. Well, I can just make x the subject of the formula here, right? If you make y, it becomes a bit complicated. So let's just make x. X is equals to y, not y, but 1 plus 2y. We can just call this our equation 1, right? And the other equation we have is 2x squared minus xy minus 5y minus 3y squared minus 2 is equals to 0. If we substitute equation 1 into this equation, so in place of x we put in 1 plus 2y, we're gonna get 2 multiplied by 1 plus 2y squared minus, in place of x again, 1 plus 2y multiplied by y minus 5y minus 3y squared minus 2 is equals to 0. So let's go ahead and try solving this. So we're gonna have 2 multiplied by, so let's solve 1 plus 2y squared, right? So 1 squared is just 1, and then 1 multiplied by 2y, that is 2y, and then multiplied by 2 will be plus 4y, and then 2y squared, that will be 4y squared, minus 1y minus 2y squared minus 5y minus 3y squared minus 2. This is equals to 0. So if we multiply out by 2 here, we're gonna get 2 plus 8y plus 8y squared minus 1y minus 2y squared minus 5y minus 3y squared minus 2 is equals to 0. So 2, let's start with the constants. We have 2 minus 2, that is 0, so that is gonna fall apart. And then we have 8y minus 1y minus 5y, that will be 2y. And then we have 8y squared minus 2y squared minus 3y squared, that will be plus 3y squared is equals to 0. So we can take y as a common factor here. If we do that, we're gonna have y multiplied by 2 plus 3y is equals to 0. So we have two terms multiplying each other to give us 0. So it's either y is equals to 0 or 2 plus 3y is equals to 0. So for 2 plus 3y being equals to 0, we're gonna get 3y being equals to minus 2. So y is equals to minus 2 divided by 3. If y is equals to 0, what is the value of x? Because we know fully well that x is equals to 1 plus 2y. So if y is equals to 0, then x is just equals to 1. On the other hand, what is the value of x if y is equals to minus 2 divided by 3? We're going to have 1 plus 2 multiplied by minus 2 divided by 3. if we compute that, we shall get minus 1 divided by 3 when y is equals to minus 2 divided by 3. That is 1.2. Let's go ahead and do 1.3. So in 1.3, given that 2 to the power x plus 1 plus 2 to the power x is equals to 3 to the power y plus 2 minus 3y, where x and y are integers, let's determine the values of x and y. For the sake of clarity, let's expand this so I can show you something. 2 to the power x plus 1 is the same as 2 to the power x multiplied by 2 to the power 1, and then plus 2 to the power x. This is equals to 3 to the power y multiplied by 3 to the power 2 minus 3 to the power y. On the left hand side, if we take 2 to the power x as a common factor, we're gonna get 2 to the power 1 plus 1 being equals to. On the right hand side, we're gonna take 3 to the power y as a common factor, and by doing that, we're gonna get 3 to the power 2 minus 1. So 2 to the power x, what is 2 to the power 1? That is 2. Then plus 1, that is just 3. So we have 2 to the power x multiplied by 3 being equals to 3 to the power y. What is 3 to the power 2? That is 9. 9 minus 1, that is 8. So we have 2 to the power x multiplied by 3 being equals to 3 to the power y. But instead of writing 8 as just 8, we can write 8 as 2 to the power 3. If 2 to the power of x is equals to 2 to the power of 3 and 3 is equals to 3 to the power of y, then our equation will be satisfied. So how can 2 to the power of x be equals to 2 to the power of 3? That can only happen if x is equals to 3. And on the other hand, in order for 3 to the power of 1 to be equals to 3 to the power of y, it can only happen if y is equals to 1. And this is the solutions for 1.3. The last equation, 1.4. So in 1.4, the equations x squared plus rx plus m is equals to 0, and which other equation? X squared plus mx plus r is equals to 0 have real and equal roots. Solve for the values of r and m if r is greater than 0 and m is greater than 0. So let's look at this. We have real and equal roots. The case when b squared minus 4ac is equals to 0. So let's use this first equation and find b squared minus 4ac is equals to 0. So b is the coefficient of x, c is the constant term, and a is the coefficient of x squared. So b will be r squared in this case. So we're gonna have r squared minus 4, a is 1, right? And then c is m, and this is equals to 0. So we basically just have r squared minus 4m is equals to 0. On the second equation, again, we're saying that b squared minus 4ac is equals to 0. We're gonna have, instead of having r squared, let's look at the second equation. The value of a is still 1, but here the value of b is m, and the value of c is r. The value of c is rm. So in this case, we are going to have m squared minus 4r is equals to 0. We're supposed to find the values of r and m, and we have two equations. We know what to do when that is the case. We can make m be the subject of the formula in the first equation, right? We can do that by saying that minus 4m is equals to minus r squared. So m is equals to r squared divided by 4. We can call this equation 1 and substitute it here. If we do that, in place of m, we have r squared divided by 4. And then we square that, minus 4r being equals to 0. So we're going to have r to the power of 4 divided by 4 squared is 16. Minus 4r being equals to 0. The 16 is troublesome, so let's go ahead and multiply out by 16. We're going to have r to the power of 4 minus 4 multiplied by 16. 4 multiplied by 16, that is 32, 64. So we have 64r being equals to 0. The best approach in this situation would actually be using trial and error. You substitute 1, you substitute 2, you substitute 3 until you substitute 4, and then when you substitute 4, the left hand side is equals to the right hand side. So when r is equals to 4, our equation is satisfied. So now we have r is equals to 4. When r is equals to 4, what is the value of m? We know that m is equals to r squared divided by 4. So r squared, that will be 4 squared divided by 4, which will be equals to 4.